And today we're going to be looking at that section of Module 1 that deals with partial fractions, okay? So before I begin, I really wanted to explain to you guys from the basics. If your memory has defeated you at this point in time, let's go back to the basics in terms of what types of fractions we have, right? So once upon a time, if you guys can remember, when you started learning about fractions, probably in Standard 4, Standard 5, I think, you would have learned that there are essentially two main types of fractions, right? One is called proper fractions, and the other is called improper. Okay, so we have proper fractions and improper fractions, okay? And if you cannot remember what proper fractions look like, they're the ones where your numerator is nice and smaller than the denominator. And improper fractions, you have an overlap or a larger value on your numerator, and your denominator tends to be a smaller value. Okay, so all of these are from the rational sets of numbers, rational fractions. And because we have a fractionated format, of course you can perform something called division. Now, partial fractions is all about observing what type of fraction you've been given, and based on the type of fractions, especially what's present on your denominators, you can actually take your fraction and of course you can split it up into parts of solutions to this one proper fraction here. Now, when we're dealing with Form 6 level math, of course you're not going to get beautiful numbers as you see on screen. Yep. It's going to be algebraic, okay? So, let me get rid of this on the board here, right? So just giving you guys your memory skills back. We have proper and we have improper types of fractions, all right? Now, we're going to begin partial fractions with a focus on proper fractions. Let me see if I can get it up there. All right, so we have proper fractions. All right, forgive me if my writing is a bit blotchier than usual. I'm using a different graphic tablet here, and it's taking a while to get used to. All right, so in proper fractions, you guys will be actually dealing with 4 different types. All right, the first type is called the unrepeated linear. The unrepeated linear type of partial fraction, meaning that this is going to be what you're going to be seeing on your denominator. Of course, when we start to do examples, you guys will begin to understand exactly what I'm talking about. Okay, so proper fractions, you'll be getting a type called unrepeated linear. Then, of course, you need to know the vice versa. So if you know the unrepeated, guess what? You're going to have to also know the repeated linear. All right. And linear, you know, with linear, you follow up with quadratic. So you're also going to have to learn about the unrepeated quadratic. Okay. And of course, you're going to have to learn about the repeated quadratic type. So these are essentially the 4 main types of partial fractions we'll be looking at today. And hopefully in this video, I can just close it off with the improper type as well. So stay tuned. Let's get into the first type, unrepeated linear. Okay, so on screen, we have what I would like to call an unrepeated linear set of factors present in this fraction on the denominator. Now, exactly what do I mean by unrepeated? All right, so unrepeated means that you're not going to see the exact same factor. For example, you have ax plus b in one bracket, and the second bracket is also not ax plus b. This would give you something like ax plus b all squared on your denominator. So that's what we mean when we say something is unrepeated, or it has unrepeated factors, right? There is no repetition present. Now, what about linear? What exactly does that linear refer to? Well, remember when you're trying to find the equation of a straight line, it's given in the form y is equal to mx plus c. All right, and this is the general format for the equation of a straight line. And you'll frequently see equations of straight lines look like y is equal to 2x plus 3, y is equal to 5x minus 4, and so on. And we would usually say all these represent straight lines that are linear because that power of x present is raised to the power of 1. So once the highest power present in your equation is 1, then it's said to be linear. Once a power changes to a form where you have something as follows: 2x squared plus 3 minus 1, it's no longer linear. It's called nonlinear. All right, so whenever you have a fraction as follows here, and you're observing at your denominator, each factor within bracket does not have a power of x greater than 1, then those factors are said to be linear or non-quadratic. And usually, generally for this topic as well, you will find that in most cases, you'll be dealing with either a linear form or a quadratic. Very rarely you would get a polynomial of degree 3 where you'll have to end up factorizing. Okay, so now that you guys have successfully been able to identify how to tell if your fraction is unrepeated and linear, then something like this simply breaks up into a format as follows. Now, to determine how many parts your fraction breaks up into depends on how many factors are actually present in your denominator. In our denominator, we actually have 3 factors, so we are going to be able to split this partial fraction up similarly into 3 separate fractions. So you can say that the number of factors on your denominator corresponds to the number of fractions you are going to get after the split. Now, the denominator of each of these splits is very easy. They're actually just simply going to be each of the factors present in the given denominator. So you simply go ahead and you rewrite this as follows. Now, once your question is of the nature it's unrepeated and it's linear, then your corresponding numerator after your split is simply constants. You can use the same letter A except make it a capital such that capital A is not equal to your common A. They're different. Now, because you have already used the letter A, you cannot write another letter A for your second fraction. Remember that variables are arbitrary. Each variable represents a different value. So for your second fraction, you'd want to use a different letter. You can use B, but make sure it's going to be a capital B because common B has already been used in your question. And finally, you can use a C to represent your third variable present there because we also have a common C present. Now I'm using the letters A, B, and C because generally in most textbooks and on the internet, you'll see A, B, and C being the most common variables used in this type of split. However, if it makes you understand the topic better by using different letters, that's fine. You can use X, Y, and Z if that's what it takes for you to understand and not make mistakes. All right, so step 1, that's how to split an unrepeated linear fraction into partial pieces. Now, this is a standard format in how you would split something. Let's look at an actual example to understand how to actually apply this rule. Okay, so on screen in green, that rhymes. On screen in green, you will notice that our denominator has no repeated factors, and within bracket, you'll notice that each of your factors are also linear. So we are definitely looking at that first case scenario where you can split this up into the format on this right hand side. Now, how many splits are we going to get? Now, because the question only has 2 factors, that means our solution is also going to have 2 splits. The denominator would be the first factor and the second factor would be there as well. And that's how you split it. Now, when you're wondering what goes on your numerator corresponds to what's present in your denominator. So once again, if it's linear and unrepeated, what you will get is that your numerator would be A and B, or C and D, E and F, G and H, whatever letters you want to use, that's completely fine. Okay, and that's it. So all that's left for us to do now is simply solve for values of A and B. All right, so we actually are looking for some numerical values for A and B. And because of the presence of that equivalent sign there are some basic mathematical skills you guys should know so that we can apply them and solve for values of A and B. Now, one of the most common first steps that tends to be done when you're doing partial fractions is to multiply both. All right, that's multiply. Multiply both sides of your equation, your identity if you want to call it that. Multiply both sides by the left-hand side denominator. Okay. You're going to multiply by this left-hand side denominator here. So now if we're multiplying the left-hand side that already has the same denominator, essentially it's going to cancel itself out. So if I were to show you the working, if you have x minus 3 and we were to multiply it by the existing denominator, you could see that it's going to cancel itself out. So that essentially what you're always left with is simply the numerator that exists on the left-hand side. Some students leave out this step because they get accustomed to what happens. So they get straight into writing down that, hey, you're just going to get on the left-hand side that numerator present. And they follow up by multiplying each individual fraction. If I can show you a bit of working, if you have A on x minus 3 and you have to multiply that by x minus 3x plus 1, remember we're multiplying both sides by the left hand side denominator, okay? So these would cancel so that you'll end up getting A by x plus 1. Similarly, the x plus 1s would cancel and you'll get x minus 3 left here if you want a bit of working to see why. All right, if you're multiplying that by x minus 3 by x plus 1, the x plus 1s are going to cancel, leaving behind that x minus 3. So as you can see, it's kind of a basic step once you get the hang of it. Whatever exists on the denominator on the right hand side, you would put the other factor on the numerator next to that A. Same with B. And getting this first line here tends to get easier with practice and time. Alright guys, so I'm going to call this, well generally you can call this an equation 1, but in this case we may not need to call it an equation 1. There's actually several things you can do if you want to solve for the values of A and B. In this first example here, I'm going to show you one of the things you can do to find values of A and B. And the first method, so method 1 if I want to call it that, let's try using black here. So one of the first methods that they will tell you to do is to observe once again from your original question, right? Observe the denominator, the factors. Observe the factors in the original fraction, right? In your original denominator. I'm giving you guys some notes. So observe the factors in the original denominator. So the factors were x minus 3 as well as x plus 1. I think I'm going to remove the brackets here actually. Okay, so let's rewrite that. The factors were actually x minus 3 and x plus 1. And what you want to do is simply set these two equal to 0. You know, when you're having factors and you're trying to understand at what value of x is that equal to 0, you set your entire thing equal to 0. This would imply that x has a value of 3 and x also has a value of -1. And interestingly enough, you can actually substitute these values into this equation here. Okay, fine. Let's call it 1. You can actually substitute these values into your equation 1, and that gives you most case scenarios that actually will be able to give you values for A and B. So let's go ahead in this question. Let me see if I can just try my best to fit everything all on one screen. Okay, lovely, lovely. I'm learning to utilize this new tablet here. Nice. So how about we go ahead and we're going to sub that value of x is equal to 3 into our equation 1. And the reason we do this is because it's going to eliminate stuff, right? On the left hand side, if x is 3, you'll get 3 plus 2 is just 5 is equal to, on the right hand side, you'll get a open bracket 3 plus 1 gives us 4. And what you'll notice is that you will get one of your variables goes to 0. And that is why they use this method. It always eliminates one of those variables present so that in the end you are actually able to get a value for your variables present. Alright, and this simply implies that I guess from here you can also just use your you don't have to use the identity sign. You can just go ahead and use your equal sign. And this implies that we have a value for A. Boom! Just like that, we got a value for A. And similarly, you can go ahead and you can substitute x being equal to -1 into your equation 1. And that will give you 2 minus 1 gives us 1 on the left. Of course, that first A is going to cancel and disappear, and then you're going to get B by -1 and minus 3. So you'll end up getting 1 is equal to -4B. So B is simply equal to -1 over 4, or -1/4. And boom! Just like that, you got your values for both constants. In the end, what do you do with these values? Well, from the beginning, right, you guys just learned the essential form of how to split a partial fraction that has unrepeated linear factors in green. All right, so this here represents the standard form your final answer wants to go into, where you're just looking 4 numerical values for a and b. And now that you've found them, you can rewrite your final answer as follows, okay? So you can simply state that, hey, the partial fraction x minus 3 by x plus 1 ends up splitting into something like this. A is 4 over 5 on x minus 3, and b is minus a quarter. Well, if b is minus a quarter, you can change the sign. All right, so you'll get minus 1 over 4 all over x plus 1. You can choose to leave them within brackets if you like, or not. Also, if you did not like to write it like this, you could have chosen to write it as follows. All right, so let me just clear this up. Here's another way you can write it. You can have your 4 on top, but your 5 in front down here. And then your minus a quarter, you could have put your 1 on top here and your 4 in front of your denominator there. So it looks nice and clean and, you know, very neat. All right, you always want to try your best to make your answers look nice and neat. Okay, guys, so pretty much there you go. That's it. That is exactly how you would split a unrepeated linear partial fraction. So this is just simply an introduction. The tutorial sessions are actually available, full past paper questions, if you scroll through my folders. I have a lot of past papers done on this. So this video in particular is dedicated to the kids who really wanted more explanation as to how to do it the first time. And when you get accustomed and comfortable, then you guys can go ahead and look at the tutorial. All right, so let's continue. We have up next, we're going to be looking at the repeated linear factors, so stay tuned. Okay, so on screen you'll see that we have a different type of proper fraction, a case where we're going to have repeated linear factors. Now, what essentially does this look like? What does it mean? Well, on the left hand side, right, I want you to look very, very closely at the denominator. Now, that first factor there, it definitely is linear, okay? It's linear because if you look within the bracket, that power of x present is no greater than 1. So it's a linear factor, right? And also outside of that bracket, the power present is also 1. So it's actually linear, and it actually happens to be unrepeated. But if you look at your second factor, you'll notice within the bracket once again, that x is to the power of 1. So it is linear, but when you look at the power outside, you're seeing 2. That is how you recognize when something is linear, but the factor is repeated. So this is something students confuse a lot. To identify if something is linear or non-linear, quadratic, aka, what you're looking at is actually what's within brackets. All right, so I'll write that as a note so that helps you guys. And if you're trying to identify something is unrepeated or repeated, what you're looking at is the power outside, all right, outside of your brackets. Okay, so I think these are the key essential things you need to remember to thoroughly understand this topic, and it really, really helps. All right, that note, I would say, write it in bold, and you'll square up this topic like nobody's business. Okay, so let's move on with life. All right. So once again, looking at that first factor present, right? It is linear and it is unrepeated. And as with all linear and unrepeated factors, I told you guys in order to split it, you simply make sure that whatever your factor is, it's present in your denominator. So your first factor was ax plus b. So you're following that same rule. And the numerator just simply takes one letter, right? A constant, if you want to call it, because letters represent variables, letters represent numbers or constants, all right? So if you really truly want an honest opinion, I always tell kids that examples that have repeated linear factors usually tend to have a mix of both linear unrepeated and linear repeated. All right, so you will have one of the factors just being regular, no power, not repeated, but the other one is a bit different. So in that case, your splits, the way you split up your fraction, is dependent on each factor that goes on a denominator. So with the first one, ax plus b takes the split of a linear unrepeated format, right? Which is why we just simply have a on ax plus b. Up next, you see when it comes to the second factor, because it happens to be repeated, our split is not the same as, hey, you have two factors on a denominator, so therefore you're going to have two splits. No, no, and no. And essentially, there's no way of ever saying there's going to be a standardized number of splits for this. The number of splits for a linear repeated factor actually depends on the power present. All right? So let me write that as well. The number of splits for a repeated factor, all right, depends on its power. All right, so forgive me, like I said, brand new pen. I'm learning to work with people, and as you can see, I'm not doing the best job, but I can speak. So that scribble in blue says the number of splits for a repeated factor depends on its power. So guys, in this question, you can see that the second factor present there, the power is 2. That is how you know how many splits you're going to have for that factor in particular. So that factor is going to give us 2 splits. And there's a special way that you actually need to split a factor that is repeated, but linear. And this is how you go. You write the factor down, cx plus d, whatever is present in brackets, and you start from the power 1. You start from the basic factor that's within bracket. And then you go ahead and you rewrite it again, but this time you increase the power, so it goes to 2. And you would keep doing that if the power were 3 and 4 and 5, and you stop when your last fraction is the exact factor that's present in the question. Okay, so let me repeat that. The number of splits for a repeated factor depends on its power. So in this case, our power is 2, so we will have 2 splits. You always begin with your first split in your denominator, starting from a power of 1. And then you keep increasing that 1, 2, 3 until you reach the designated power that is present in your question. In our case, because the power is 2, we will have our first split having that power of 1 and our second having 2. As we do more and more examples, you'll get the hang of it. Okay, it gets better, and it's actually a really nice topic. Now, you guys are probably wondering, I'm going to just erase that because the power of 1 is understood to be there, okay? You guys are probably wondering, okay, just something new, but what about the numerator? What would the numerator look like? Well, good news for you guys. Whether you're dealing with unrepeated or repeated factors, once within brackets is linear, meaning it's not a quadratic within brackets, then your numerator still contains standardized variables A, B, and C, or D and E and F if you had more factors associated with it. Okay, so that's good news, all right, for linear stuff. So that is essentially how you would go about and split a repeated linear factor. Now let's see how to apply this split in an actual question. Okay, so hold up. Okay, you guys ready? Now, this is a booming example because sometimes when stuff like this comes, students do not recognize this down here as a factor by and by itself. It's actually, if you want to think about it, it's just x, you can say subtract 0 plus 0 all squared, if you want to think of it as a factor. Okay, so yeah. So it is a factor by itself. And as you can see, x standing by itself, if it belonged within brackets, if I'm going to use the screen here, if this belonged within brackets, then within brackets, it's linear. Okay, it's a linear factor. And also the second x plus 1 is also linear. However, that first case scenario, it's to the power of 2. So that x squared is actually what you call a repeated factor. And when we have repeated factors, remember this number of splits depends on its power. So its power is 2. So we're actually going to have 2 splits present. And our denominator is going to start with the standard basic x. And then we're going to keep increasing that power till we reach the desired power given in the question, which is squared. All right. So that is how you would split this first factor. On the numerator, we're going to associate it with A and B. And then lastly, you can see the second factor present is simply a nice unrepeated linear factor. So it just has that factor on the denominator and we associate it with a standard variable. You cannot use the same variables on the numerator, guys, because variables are different. They represent different numbers. I don't know why some students use A, B, and A again sometimes, saying, well, it's a different factor, so we could use A again. No, no, and no. The aim, the purpose, and the intention of all of these different types of format, guys, is essentially to split the fraction into simpler forms as well as find values for A, B, and C, numerical values, all right? And if you can recall from our first example, remember we multiplied both sides by that denominator present on the left-hand side? Well, guess what? That's the standardized method for all partial fractions, right? So after you generate your standardized split, I call this my split, S-P-L-I-T. This is my standardized split. After I create that, then my next step would be to multiply both sides by this denominator present on the left-hand side. Multiplying both sides, right? Multiplying both sides by, we're going to multiply by x squared by x plus 1 is going to give us, on the left, you will always get back your numerator, which is just 3x squared minus 1. And on the right, if you can actually eyeball it, your denominator is x. So that's going to cancel out with one of those x's present there. So you're going to get ax by x plus 1. Also, that x squared is going to cancel with x squared there. So you're going to get b by x plus 1. And then c, you're going to get x squared because this x plus 1 is going to cancel with that x plus 1. If you want working, essentially what we did is we multiply a on x by x squared by x plus 1. So these cancel, right? That's how we got that one. Just showing you guys a quick working because I know some of you guys may not be as quick on the buzzer as others are, and that's okay. We all work at our own pace, okay? X squared by x plus 1, what's going to happen is that these are going to cancel. Essentially, you alternate what's going to cancel. If you eyeball it, you'll see it in a couple steps, right? After a couple practice questions, you'll get the hang of it. But after you multiply both sides, each individual fraction on the right-hand side by that denominator, this is what you would end up with. Now, previously, I showed you a method where you can observe what's present on your denominator the factors present in your original denominator. So this is our method 1 that I showed you guys, right? If you observe the factors present, we have x plus 1. And if we set that equal to 0, we could use the value x is -1, and we can substitute it into this equation 1, and we can see what we get. So how about we try that? Let's substitute x being equal to -1 into our equation 1, and let's go ahead and see what we'll get. On the left hand side, if x has a value of -1, you would end up getting 3 by -1 squared minus 1 being equal to, on the right, you will get, if x is -1, you will get a by -1, but then you have x being -1 here. So you'll actually get -1 plus 1. So that just cancels. Everything's turned out to be 0 there. Similarly with b, you will get -1 plus 1. This cancels to 0. So you just end up getting c by -1 squared. And this works out to be, I believe, 3 by -1 squared. That's 3 minus 1. That's 2. And on the right hand side, -1 squared is +1. So you'll get c being equal to 2. Not do. And boom. Just like that, you got a value for c. Now, we only have to find values for a and b. A second, using method 1 as well, you can also substitute a value of x being equal to 0, because essentially we have the factor x squared. So if you wanted to set it equal to 0, you can actually use x being equal to 0, right? So another value you can try is when x has a value of 0. All right, you can substitute this into equation 1. So substitute when x is equal to 0 into equation 1. And what does that give us? If x is 0 on the left hand side, we're looking in green, people. This is our left hand side here. You will get -1 on the left being equal to, if x is 0, well, that first term goes to 0 over here. Everything just goes to 0 there. If x is 0, we will get b, open bracket 0 plus 1. So you'll just get b there. And then if x is 0, this also goes to 0 as well. So you end up getting b being equal to a value of -1. And boom, just like that, we got a second value for a different letter. So guess what? All we need to find is the value for a. So method 1, we have actually run out of denominators where we can just randomly set them equal to 0 and substitute values to get the corresponding variables present in question. But do you know a second method is actually to equate coefficients? Yeah, you can actually equate coefficients. So for example, if I were to go to the side of what we have written in green there, okay? So I want you guys to really focus on what we have written in green over here. Actually, let me enlarge this so that you can see it. Okay, so in green, you can see that we have on the left-hand side, we have some coefficient in front of x squared, and we also have a constant. And on the right-hand side, if you were to expand ax by x plus 1, you would get ax squared, because ax by x is ax squared, and then ax by plus 1 just gives you ax. All right, similar, if we expand brackets here, we'll get bx plus b, and then we'll get cx squared, and that's on our right-hand side. So now what you can actually do is you can equate coefficients of your left and your right-hand side. So on the left-hand side, if we were to say that we wanted to equate the coefficients of x squared, all right, so trying to get everything on one screen here, guys, trying really hard. We'll have to do it like this. So equating, let me use a different color. So equating coefficients coefficients of x squared. On the left-hand side, you're going to get 3 being equal to on the right-hand side. So we have this 3 here. It's equal to, let's see, we have a, that's a coefficient of x squared on the right. What else do we have? We have c. C is also a coefficient of x squared on the right-hand side. So you're going to get 3 is equal to a plus c. Now, unfortunately, in most case scenarios, when you equate coefficients like that, you're going to get a mixture of variables being equal to a number. But the good thing is, you should have been able to generate values as well previously for some of the letters where you can substitute them into your equations. So for example, we did get a value for c. We found that c was equal to 2. So over here, because c was equal to 2, you can actually use that value and you could get that implying that your value for a is simply equal to 1. And boom, just like that, we found all of our numerical values for our 3 different numerators a, b, and c. Right? So that's the hardest part. Getting those values requires different methods. Right? You have to either equate coefficients of x squared, x cubed. Sometimes you have to equate constants. And sometimes you just have to set your denominator equal to 0 and use those values. Whichever method you want to use is completely fine. It just takes a bit of practice. Okay, guys? But the fastest way, like I said, is to substitute values of x so which denominator is 0. That's usually the fastest way for finding the values of these constants. Okay? And let's actually put this answer together. So this is not the final answer. When you're done, you need to go back to your question, what is in green up here, and you need to tell them that, hey, I did split my fraction up. My fraction of 3x squared minus 1 all on x squared by x plus 1 ended up splitting into the following. I got a to be 1. I got b to be equal to minus 1, so maybe we can change this plus sign to a minus here. Right, so that's minus 1 on x squared, and then finally I got my c to be equal to 2, so that's 2 on x plus 1. You can keep your brackets if you like, you can leave them out once your question is not affected mathematically. Alright guys, and that is your final answer. So a final answer never has any of those constants present, those a's and b's and c's. They shouldn't be in your question. The only variable present should be x. Alright guys, and that is essentially how to split a partial fraction that happens to have repeated but linear factors involved. Next up, we're going to be looking at a case scenario where we have quadratic factors. Up next. Okay, and we're back. And the format you're looking at on screen is, dun, 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 it's very straightforward. So you'll see the same type of format, except notice I'm always using 2 factors on the denominator. I just want you guys to take note that the denominator does not always only have 2 factors. You can have 3, you can have 4, you can have 5. All right, so time's sake, those purposes, I'm only showing you cases where you have 2 factors, okay? All right. So that first factor present there, all right, that's just ax plus b. You can see within bracket, there's the power of x is 1, so that makes it a linear factor. And also outside, the power is also 1, so it's not repeated. So that splits into our standard a on ax plus b. Looking at our second factor, it's not repeated because the power outside brackets is 1. However, you can see that within bracket, you have x squared, which means we have a quadratic present. This is a case scenario where one of your factors is no longer linear, it's quadratic. And I know you may be asking yourself, whoa, this is going to be a very, very terrible split. Actually, it's even easier than the repeated factors split. This is how to split a factor that is actually, once it's not repeated, this is how to split it when it happens to be quadratic. All right, so you simply write your factor on your denominator with your brackets or without your brackets. It does not matter. I like brackets personally. And on your numerator, that is what changes. All right, so whatever is present on your denominator is always closely associated to what is placed onto your numerator. Whenever your factor is a quadratic, your numerator takes a special form. And the format it takes is bx plus c, or cx plus d, or dx plus e. Just make sure when you're using variables, you do not go back and use variables that have already been used in your question. So you can see that our first split already contained that letter A. So for your second split, you cannot go back and use ax plus b. You have to start from b, all right? And because this quadratic factor is not repeated, you're only going to have one split. Only when you have repeated factors, when you have that outer power being greater than 1, do you have multiple splits. So that's it. That is it. So for linear factors, your split just has like one constant on top, and for quadratic factors, your form on top is bx plus c or ax plus b based on how many splits you have. Okay, and that's it. Let's look at an example so I can walk you through how to do one. So let's consider so I'm actually using a, shall I do a whole different example? We can. Let's do something very simple. Let's do a simple one. So consider this question here. We have 3 on x by x squared plus 1. Okay, so that's a nice simple one. And we recognize that we have quadratic factors present, okay? The first one is not quadratic, it's linear. So that splits into a simple a on x. But the second one, it's not repeated, so we're only going to get one other split. However, your numerator is going to be related to that split in the form bx plus c. All right? So once you're finished doing your nice little split, it's time to go ahead and solve for the values of a, b, and c. And remember step 1, you want to multiply both sides by your common denominator present on the left hand side. So multiplying both sides by x squared plus 1. Let's see what we're going to get here. On the left hand side, you will be left with that 3 as always. That's the intention. And on your right hand side, if you multiply a on x by that entire thing, the x's will cancel such that you'll get a by x squared plus 1. Similarly, for your second part of that numerator, if you multiply bx plus c, that x squared plus 1 is going to cancel and you're just going to get x next to it there. And if you want, you can call that equation 1. You continue. You can use either method where you set your denominators that are present. You can set them equal to 0 if you like. To solve for possible values of a, b, and c. Let's see if we attempt to use when x is equal to 0, what happens. When x has a value of 0, we will get 3 on the left hand side is equal to a by 0 squared is just 0, 1 plus, you will get b, 0 plus c, and also that entire thing is 0, so this just disappears. So that's the beautiful thing about these types of questions. And boom, just like that, we got a to have a value of 3. All right, so we got one value there. How about we start equating coefficients? Now, if you want to equate coefficients, it does help to try to do one more step where you expand your brackets fully. Sometimes people can eyeball it and they can see. Sometimes you can make a mess and make mistakes, right? So on my left hand side, I'm actually seeing that we have the constant 3. If I will, let me show you guys something. Let's just say I wanted to equate constants, right? I'm just showing you guys something here. If we equate constants on the left of this equation here, you can already see we have 3, but then on the right, the only constant present is a. But we already got a value for a. So essentially equating constants does not help us, right? So when you're wondering what you have to essentially equate, it takes a bit of effort. You need to look through your question and see what's the best things you can actually equate, such that you can generate more solutions for your answers. So in this case, equating constants is not going to help. How about we equate coefficients of x squared and see what happens. So on the left, coefficients of x squared are obviously 0 because there are none. And on the right hand side, the coefficients of x squared are a plus b. And then we also found the value of a previously to be 3. So this just implies that 0 is actually equal to 3 plus b. And this implies that b has a value of -3. And boom, just like that, by using a touch of brilliance and common sense at the same time, we got a value for b. And similarly, we can even try to equate coefficients of x. So let's see, if we were to equate coefficients of x, what's going to happen? On the left, we'll get 0. Use a different color. On the left, you'll get 0 is equal to, on the right, let's see, coefficients of x is just simply c, right? So therefore, boom, just like that, you got your value for c, and c happens to be equal to 0. So now, when you're finished getting all your variables present on your numerator, you just simply have to substitute them back into your main split. All right, and just so you know where that took place, this is your main split right here. Okay, this is your main split. So your final answer will turn out to be x squared plus 1, ended up splitting into the following. A had a value of 3, so that's 3 on x, plus b has a value of -3, so that's -3x, and then c has a value of 0, all on x squared plus 1. And of course, we can clean up this numerator. 0 doesn't need to be there, so we can eliminate that plus, and we can change this sign to a minus, and we will get -3x. And that's it. That is essentially, how you would split something that has quadratic factors present. And also you'll notice that when you're splitting stuff that has quadratic factors present, generally, because of the standardized format, your numerator will have some version or form of a variable present x. All right, so expect it. And if you don't get it, chances are you probably made a mistake somewhere along the line. So just check. All right, guys, so that is how you would do questions involving quadratic factors that are not repeated. Finally, we're going to look at a case scenario where we have repeated quadratic factors up next. Okay, guys, so for this last type of partial fraction split, we're actually going to get into it straight via an example, because you guys have already learned how to split something if it's repeated, and you've already learned how to split something if it's quadratic. So putting those two types together, you're going to be able to work this without having a standardized format of split. So let's look at that first factor present on the denominator. Now, that factor is indeed within bracket, it's a quadratic. It's x squared plus 4. And remember, when you have a quadratic factor on your denominator, your split has a special corresponding numerator. So you're going to write down that factor first of all. You have x squared plus 4. We're going to hold off writing the power just yet. We're going to relate that quadratic to its associated type or form. of numerator, which is ax plus b for quadratics. Now, how many splits will this repeated factor take? Remember what a repeated factor is. When you have a power that's outside of your brackets, it's repeated. And your power tells you how many splits you're going to end up getting. So because your power is 2, we are going to have 2 splits for that factor. And yes, just had a break in thought there. Had a phone call. Anyway, guys, so yes, I was saying when you're splitting repeated factors, the power tells you how many splits you're going to get. So in this case, we're going to have a second one related to that repeated factor. And remember, when you're splitting repeated factors, you write what's within brackets. You start from the power of 1, and then you keep increasing till you arrive at your designated power that exists there. So this is how this split is going to take place. And not only is it going to take place like that, once again, because within bracket, you have something called a repeated quadratic factor. You also have to make sure your numerator corresponds. So because we already use the letters A and B, we'll have to use CX plus D. All right. So this can be a little confusing. This first time you see it, you really need to understand. First of all, you observe your type of factor. If it is repeated, then you have to do a certain number of splits to accommodate that power. And your denominator starts from the power of 1 and keeps increasing till you reach the designated power present in your factor. After you're finished observing that power, then you're finished with your denominator. You need to go to your numerator. And to understand what has to be written in your numerator is associated with what's within your bracket. So if within your bracket happens to be a quadratic, then your associated numerator would be the form ax plus b. So our first 2 splits are associated with a quadratic factor, hence the format in blue. Now our second factor, if you look at it, is not repeated. So we're actually just going to have 1 split present, and we're going to write that factor x plus 1 on the denominator there. And then to figure out what goes on the numerator, we look within bracket. Within bracket, x plus 1 is not a quadratic. That's a linear factor. And for linear factors, our associated numerator is simply 1 letter, 1 variable. All right. And because we already use A, B, C, and D, we will use the variable E. Remember, constants are just arbitrary. All right. And that's your split. Now, essentially, a split tends to be what your answer, the form your answer wants to look like. This is your split. The only thing that we need to find out is the values for A, B, C, and D, and E. That is why we go about and we perform different mathematical operations in an attempt to find values for A, B, C, and D. So some of the things we can do, first step, like I say, we always multiply throughout by this denominator present here. All right, so we're going to multiply throughout by x squared plus 4 squared by x plus 1. And usually that always gives you on the left-hand side just the existing numerator. And on your right-hand side, that's going to give you ax plus b by x squared plus 4 by x plus 1. If you need to understand these steps, it's best to write down your first fraction very gently, take your time, and then multiply by x squared plus 4 all squared by x plus 1. Observe what gets cancelled. This cancels with one of these powers, which is why you ended up getting what I have on top. All right, so if you need to take the time, step aside, really take it slow steps, simple steps, till you get the hang of being able to do it very quickly. All right, and next one, you will get cx plus d by x plus 1. And for that last split, you're going to get e by x squared plus 4 all squared. All right. And I can tell you guys what you need to do. Over here, you also would look at your denominator. You would substitute values. So when you set your denominator, each of those factors equal to 0, you can try substituting x being equal to -1 on both sides. And that would give you, let me see, if x is -1 on the left-hand side, you're going to end up getting 9, because -1 squared is just +1, so that's 2. -1 gives us 1 plus 8, which is 9. And on the right-hand side, what you want to do is look through things that would make your entire variables go to 0. So if x is -1, these two first terms actually will become 0, because -1 plus 1 gives us -1 plus 1 gives us 0. So if this is a multiplication by these two other terms, this entire thing goes to 0. All right. So similarly, for the second term as well, you can see that happening right here. So you'll just end up getting e by -1 squared, which is just 1, plus 4, which is 5 squared. And this implies that e gives us a value of 9 on 25. All right. And boom, just like that, we got a value for e. And you can continue doing this. You can equate coefficients of x squared. You can equate coefficients of x cubed. You can equate constants on both sides, and you would get values for a, b, c, and d. On screen, what I'm going to do is, because that's more algebra, I'm going to let you guys take your own time. I'm not going to show all of that working on screen, but I will tell you guys what values you're hoping to get. Right? You're hoping to get values for a being equal to -9 on 25. You want to get a value for b being equal to 9 on 25. All right. You're going to get a value for c being equal to 1/5. And you're going to get a value for d being equal to 4/5. Okay, guys, so there you go. And we got the value for e being equal to 9 over 25. You put your answer together, and you can simplify it whatever form you want. You can bring down the fraction if you don't like how it looks. You can leave your fraction on top. You can factor out things. The answer I have, I'll share it with you guys. If you want to make your answer look pretty nice and presentable, you can have a textbook looking answer like this. All right. Not that this is the only way you can represent your answer. This is after you've cleaned it up a bit. You've chosen to write some of your fractions as follows. All right. Plus x plus 4 by 5 by x squared plus 4 all squared plus 9 over 25 by x plus 1. Yes, so that's it, people. So e, you can see that 9 over 25 in that last one there, and the a being the negative 9 over 25. You can see us flipping signs, that 1 minus x, changing things around a bit there. With the b being positive 9 on 25, but 9 on 25 was factored out. All right, but one thing you'll definitely see is that the denominators of your split are present on each of these here. All right, guys, so that's about it. That's how you would split something for repeated quadratic factors. All right, so that's about a wrap. Please look at my tutorial videos. You will not understand collectively how to do these questions until you put pen to paper. It's easy to look on screen and follow along what somebody does, but you only really get those steps sealed in your memory when you start working it out yourself. So let this be a first example, because I have some missing steps in between because I didn't show you how I equated coefficients to generate values for A, B, C, and D. So how about you guys try that now and see if you can get at least those values. And if you did, good job. You know how to do algebra really good. All right, and for further clarification on this topic and more past paper examples, I have a full tutorial on partial fractions uploaded. Just check the different modules present and you can look at the entire tutorial. And once you cover that tutorial, trust me, you guys are good to go. You get every single partial question correct that can come. All right, just a little pointer to note, because the last past paper that came had something. I just want to show you guys something. So whatever you have in your numerator, right? Let's just say you have something like x cubed minus 2x squared plus 4x plus 1 or whatever it is. What if a case scenario happens like this and they ask you to split this up into partial fractions? Well, guess what? It did come. And because of this x cubed and they're essentially not being like brackets of factors present, kids, they just like lost their minds. And essentially, if something like this comes in your year, what you need to do is you need to factorize your denominator. All right, so sometimes in very rare circumstances, they will give you a polynomial and they would not have it in a nicely factorized format like this, where the factors are clearly seen. So what you would need to do is factorize this, right? You need to find a value for x that, remember, if something is a factor, f of that value, whatever the value is equal to 0. Right, so you set this to be equal to your function f of x and you try various values. F of 1, is that 0? And if it is, then x minus 1 is a factor, and so on. And then sometimes you may have to do that famous long division where you'll definitely need to do it. If you find a factor, let's just say, I'm not saying for this question 1 is a factor, x minus 1 is a factor, but if it is, then you would have to perform that long division. So you would have to remember how to do long division. You can find a quick tutorial on long division present in my videos in AdMath for when you're doing like long division like this. I do have a tutorial up if you guys need a refresher for that. But this question did come, and students stopped completely when they could have gotten, like, I think it went for like 12 marks or something like that. So just little things like that, you know, little twists and turns like that. I mean, you have the basic knowledge of what to do if, but because you're stunned by the format they gave the denominator in, it wasn't previously factorized, you just gave up. So don't give up. Right? It's always that you know how to do something, you just need to recall. And the more experience of different types of questions you see, the better chances of you being able to attempt the question even faster, guys. So that was the end of partial fractions. I hope the video was helpful. I really hope I didn't make any mistakes anywhere, because I usually make mistakes. You know, 2 for a 5 and a 3 is a 9. But hey, it's maths, okay, guys? Once you understand your standardized proofs, your formulas, how to apply them, I'd say that's the important thing, right? We have calculators for working out 2 plus 2 and stuff like that. But anywho's, please look out for more of my videos. I will be trying to do one on implicit differentiation and get into integration as well. So stay tuned. I'll see you guys again. Take care and goodbye.